So hopefully, did all of you guys get to answering the questions? Let's see, we have 27. That should do for now. For those who missed the very first few minutes of class, I had everyone go to the labs page and click the class survey, and that took us to this class survey where everyone filled it out. And now we have 27 people who filled it out. And just keep this in mind for if you have these surveys on how to do it for when you download the data for your own research. So we're going to download the responses. Let's see here. And it put it automatically in my downloads folder. I'm just going to keep that in mind because now, let's see here. What do I want to do? Let's see. I'm going to turn this one off. Yes. So for this one, I am going to add the data to past data that I have had for this class. Oh, I want to keep that. I want to show that one to you later. Okay, which should be here. Okay, so I've actually collected a lot of this data from past classes for this one, and I'm going to add yours to it. All right, it should be the same layout. Let's see. We have age, that goes to P. Goodness, move. Okay, now the way I'll do it is I'm just going to copy. Copy. I hope this works. Let's see. Somehow I'm missing one. I wonder what it is. That's strange. Oh, I see what happened. Okay. The age category is in the wrong place, so I'll fix it. Okay, let's see. All right. It's taking longer than it should. Hopefully, just ignore all this if you find it confusing. Okay, so this one here is like the last several classes. It's just, so for the past 5 classes, I have collected this data, and you are number 6. And you might recognize this from the videos. Whoops, I don't want it to go down that far. There we go. It filled it all up. Now the data is correct. And I'm going to save it and make it available to you. Where did it save to? Right here. Hold on a moment. This won't take long. Oh, it's not working for me. I knew it was going to do that. Okay. Upload. They always pick the day that I'm in class not to do that for me.
Professor, I think it didn't save because you already had an Excel spreadsheet under that same name.
Actually, it would have said, do you want to replace it?
Oh, okay.
Sometimes I use GoDaddy for my web. Pardon me?
I think it did say if you wanted to replace it.
I don't know. Let's try this. I have to go directly to the website sometimes. Let me see here. Class survey, it should go. Lab docs. Yeah, it's being finicky, but that's okay. I think I know why. It thinks it probably has me signed out. That's okay. Now let me update the web page. Okay, that one went. All right, so if you go to the labs page, refresh it. Class survey data, you see it there? Save that to your computer.
I'm getting a server error.
Yeah, so am I.
Let me see what it does. Oh, it went to the wrong place then. Let me see where it's going. Class survey data. Huh, that folder is acting awfully finicky. Let me get it into, it should be lab docs. Lab docs, yeah. Lab docs, class survey data. Back. I know what's wrong. Let me fix it. So annoying. Oh. Okay. Sometimes it doesn't like spaces. Now let me see if it'll go in. Okay. Seems like it might have gone. Let me check the spelling here. Class survey data. Okay. Let's see what happens with that. Refresh. It's being so weird today. Oh, that's lectures. I'll have to refresh.
It works, Professor.
Yay!
Good job.
You guys are getting a lesson in HTML too.
Oh gosh.
Before we're done, you'll learn how to do your own website, right? Okay, so, all right, now you should have your SPSS open. Maybe I'll delete that. Yeah. I'm gonna delete this. I'll do this later. Okay. I'm gonna take this out too. Okay. Now, if you remember this, our data, your data probably went to your downloads, right? So if you go import data, Excel, and you find that class survey data, hopefully this is the same one. Nope. I have mine saved in a different place. I have mine saved. Where do I have mine saved? Okay, where is it saved at? It is in, oh, labs, it should be there. Hopefully I got it this time. So once this box pops up, just hit OK, but just so you know, this is in case you have kind of messy data and it's not really laid out well. If you use this box, it's kind of a data wizard. It will help you get it organized so it can be accepted into SPSS. But this data is very clean. It has titles and everything. And so it reads it just fine automatically. Hopefully I got the right data.
So Professor, you're in SPSS right now, and then you went into File to import data?
File, yes. Import data, Excel.
Excel. Okay, and then you hit OK.
Uh-huh.
Perfect.
Okay, so I want to kind of switch back and forth. Just so you have an idea when you're doing data collection, let's see, do I have that survey here? No. Let's look at the survey here. Okay, so when I created this survey, if you remember, now that you have your data in there, I'm going to kind of explain all this so what we do here makes sense. So I'm going to go to the statistics page and remind you of the data types and how we select tests and how, you know, if you remember, we did some work with the difference between continuous and categorical variables, right? And the continuous variables are all interval or ratio data, and the categorical variables are ordinal and nominal data. We need to tell SPSS what are what, so it knows what kind of statistical analysis it can do, and so it will do it properly. Now, when we're looking at a survey that we create, we should be able to look at our questions and know, based on the question we're asking, what kind of data we're going to end up with. So if you just ask them their age and leave an open box for them to answer, they're going to put a number between, you know, the time of, you know, when a person can start writing to, you know, before death. That's quite a span. So that would be continuous data, right? There's no categories. There's no ordinal categorical type of data. It's continuous data. Here for gender, we gave two options. So that is a category. There's two categories. And here, when I designed this question, you can see that, and this is something I want you to keep in mind when you're creating your surveys. If you do them in forms in Google, you have to change your Likert scales to numbers, because otherwise it'll spit them out as words. So for example, let's put it in here. If I made this like a scale, and then I gave them each a word to designate what they each meant, it would give it a word like dislike instead of the number 1. And when I downloaded my data, instead of it having a 1 here or 2 or 3, it would say dislike, don't care, or like instead of the number. And we want the number so we can run statistical analysis on it. I'm going to have to fix it. So, yeah. Now that I clicked on that, I gave myself a headache and I have to do it over. But you get the point. So when you're creating your surveys, make sure you're giving them options and doing it smartly, that the answers that they end up giving you turn into ones instead of, or turn into numbers instead of words for you. So you don't have to change it once you get it into your Excel. Okay. All right, so where am I? Okay, so now we have our data here, and it has nice nice headers and so on. In SPSS, it should look like that if your data view button is highlighted. This is the data view. If I click on this button, it's the variable view. Data view is just kind of, it looks like Excel, right? All your data going up and down, or each a variable. Here's your age variable, whether they like sports variable, reading, and so on. If you're looking at it going across, that represents each individual person, right? So this is one person who is female, 21, and so on. When I click on variable view, this is where I code my data to tell SPSS what it is. This is kind of the brains of the operation here. So for the first one, you can see these are the titles of the variables it brought in from the Excel worksheet, because the top row all had titles. You can give it a label. So when it actually does analysis, it will spit out the final outcome with a label on it. It helps you not to be confused later when you go back and look at the output and know what is what. It might just have labels that are generic and don't tell you what it is. So what I do is I like copy all of that. I highlight it, copy, and I will even put my cursor here. I think you have to highlight it all, and then paste. So it'll give your labels to the final product when you do your analysis, and it comes out in the output. All right, so here, this can be very important. The type, sometimes, or most of the time, SPSS is pretty good at guessing that what type of data you have, but sometimes it's not. The options here are several different kinds. For the social sciences, typically we stick to numeric, date, string, types of, and even dollar amounts. We might ask people how much they make. Sometimes we'll use that. So we tell it which one it is. All right. With just tells you, tells SPSS how long it is. So if this is, oh, by the way, a string data type is words. It means that data is words. It's not numbers, it's not a date, it's not dollars, it's words. And if you go back and look at the data view for gender, you can see that it is all in words. And it gives you the max is 6 spaces to put in the words for this particular one. If this data value was like people writing whole paragraphs to an open-ended question, this would be a lot larger number. Decimals are for however many decimal points there are after the whole number. So if I had age and I wanted to give it 2 decimals spaces after, you'll see that, oh, it's not going to let me for some reason. Let's try it in maybe another one. Nope. It's reading, it's telling me that that's the improper, so I'm not going to fool it that it's, but you can, if you have more ratio type data, it will let you do that. Okay, so we'll go over values more in a moment. And measure. This is probably one of the most important things that we need here. For class, you can see it's labeling it as nominal instead of ordinal or scale. If you recall, I put on the statistics page that sometimes the continuous data is called scale data in SPSS. SPSS lumps interval and ratios together and calls it scale data. It does keep them the same for categorical data. It will distinguish between ordinal and nominal in that case, as you could see when I clicked on it. So here you have to make sure it is fitting the data. For gender, it is saying nominal, and that's correct because it's just there's no order to gender. It's just nominal. For class, you might be able to get away with calling it ordinal, but we'll keep it nominal. Age is definitely scale data. And the last two questions about how likely you yourself are going to be divorced or others is also scale data. And you can see here, it's labeling these likings for sports, reading, and so on as nominal, when in fact, this is actually ordinal data. There is an order, right, to this. So what you should do is, to make this go quicker, I usually click on, ordinal, and I bring my, my clicker out of there, and then I hover over it, right click, copy, and then I highlight those ones, right click, paste. You can do the same operations with the edit tab at the top, but that will quickly fill them all out. And nominal. For shyness, it was more of a Likert scale. Some people use scale because this was 1 through 5, if I'm not mistaken here. And a lot of people like to make Likert scale data. And I kind of am in that camp too, because I usually end up adding it all up together in the end and making it a final score anyway. You don't usually use these. So I am going to change these to scale data. So click out again, and then right click, copy, and then highlight, paste. Okay, so with these shyness scores, this is something you really should keep in mind when you're using someone else's survey, or you've created a survey. And there is something called reverse order questions. And let me show you what that means. So when we go to these shyness questions, here you see this one says, I consider myself to be shy. Well, if they answer a 5 on that, that means that they strongly agree that they are shy. So a 5 would be a lot of shyness, right? But if you look at this question, it says, I love to go to parties and be with people. And if they click on a 5 in this case, this means the opposite, right? It would mean they're really not shy at all. So this is a reverse order question from this set of 4 shyness questions. So we need to reverse order, we need to recode this in SPSS to make 5s represent high shyness and 1s represent low shyness for the reverse order questions. And because I've been doing this forever, I happen to know both question 2 in the shyness questions and question 4 are both reverse order questions. So we need to change these around. If you look at the data view here, you can see they go 1 through 5s for these question 1, 2, 3, 4. So we need to change question 2 and question 4. So if you go to transform and then recode into different variables, we're going to change those two. Click on recode into different variables. And we're going to do this for both question 2 and question 4. Okay. We have to give them names because this is going to create whole brand new variables for these two questions. So when it puts them out, spits them out, it gives them a new name. So I'm going to put Q2, whoops, Q2 recode. And for that, you cannot have a space in it because it will give you an error if you do. So don't put any spaces or any strange characters in there. It won't allow you to do that. You can here if you want, but I usually just leave it the same. Recode. Whoops. All right. So after you input the new name for the new variable, click change. So you can see it's going to change it to recode. And you have to do that same thing for question 4. And then click change. Okay. Now click the old and new values button. Click the old and new values button. Okay. So we want to change our 1s to 5s and our 2s to 4s and so on. So we're going to put in a 1. This is the old value, 1, and change it to a 5. Where it says new value, put 5. And click add. Click add. And do that for all of them. We want to make the 2s 4s. And I know this sounds strange, but you actually have to tell it to make the 3s 3s. Otherwise, it will just ignore them completely and leave them all blank. And make the 4s 2s. Make the 5s 1s. Hopefully you all have that. Stop me now if you're not done. Okay, I'm going to hit continue and then hit OK. Now this box pops up to let you know what it did. Okay. In fact, if I copied all this and created a syntax file, I can run this later automatically by hitting one button. I can redo everything I just did by hitting a button, but that is more advanced. Okay, now go back to variable view if you're not there already, and you can see it gave us the 2 new variables, and it labeled them nominal, unfortunately, so we're going to change them to scale. Oops, cancel. All right. Now I want to put my data in order because when I start analyzing things and stuff, I like to, it's hard to find if it's not kind of neatly in order. So I want to move these 2 reverse order questions out of the way and put these 2 new ones that I just created into the correct places where these were, right? So if I highlight the number 2 one and kind of wait a second and then click and hold, I can drag it down to the end. And then do that for number 4 also. And then click and hold and drag it down to the end. And then do the same thing for the new recodes and drag them up to where those were. This just keeps you from getting confused and disorganized. Okay. Now, let's see. The next step I want to do is, okay, I am going to show you how to do, we're going to give the labels to the values. We're going to give labels to the values. So if you look back here, where I had messed this up, we can see that ones equaled dislike, twos equaled don't care, and threes equaled like. I want to tell SPSS that's what the ones, twos, and threes mean for all of these questions here, right? And that's what this is for. So if you go here where it says values, I want to tell it ones mean dislike. Click add. Twos mean don't care. Add. And threes equal like. Hopefully you stop me if you're falling behind. Either that or you said, screw it, I'll do it later. So we'll just keep chugging along here. Okay, I'm going to click OK. And just like before,
So
I
you
want
want
to
to make sure, Professor, that you want to make sure that you label each value before you add them all, right?
What do you mean?
Like you transferred them over after, so you put one dislike. Yeah, so in that box there, you added them before you did okay, right? So we don't do them like one by one.
Oh, so like if I had another value and I said blah blah blah, then you hit add.
Right.
Yeah.
Okay.
Yeah. Okay. So just like before, click out of it, hover over that, right click, copy. And then for all these ones, you can kind of tell them. They say INDV, INT. You want them all to be labeled the same, right? If you remember answering those questions, it had the same Likert scale for all of them. So I'm going to highlight all of those. It goes to right there, right click, paste. And it just puts the values for all of them. Okay, now if I go into data view, oh, see, for these new recodes, it gave me decimal spaces, you can see. And let's see. Yeah, see here, it gave me 2 spaces for each one of those. And if you don't want them there, you can make them disappear. It really won't do anything. It's just your own preference. And now they're gone. But if you recall, we just labeled these INDV, INT, movies, travel, etc. We gave them all labels for 1, 2, and 3. But as you can see here, they still look like numbers. Well, if you want to see what the labels were, if you click on this little icon that has a 1 and an A on it, it will change it for you. See? And there you go. Okay. Okay. Click on and off. All right. Now, if I were going to do analysis on the shyness scores, I could also give them labels from agree to strongly agree, but we're not going to analyze them individually. We want one shyness score so we can run analysis for a person's total shyness based on these 4 questions. So instead, I want to add up those total scores or find a mean of those total scores to come up with a total shyness score. So to do that, I think, yeah, you go to transform again and then compute variable. It's the very top one. And click on it. And we're going to give it a name here at the top. We're going to compute a new variable, and we're going to give it total shyness score. And just like before, you cannot give it a space or any other strange characters. They have to all be kind of connected. And we're going to find, we're in this case, we'll choose, we're going to make a mean out of all of the scores. So let's look for that function. To find it, go to this function group. They're all in alphabetical order, and find statistical and click on it. And then you can see you have the option for mean. Highlight it and push it up with this arrow. And you can see it has like these parentheses with question marks and a comma between the question marks. This is just sort of giving you a visual of what the data, they expect the data to look like once you've entered it all in there. So what it's saying is, put a variable here where this question mark is and a comma in between all of them. So we want to add the shyness score. So it's highlighted. So once I stick something over there, it will delete it and put it in place for this first shot. So I'm going to put in question 1 for shyness and move it over, and you can see it, put it where that question mark is. And there's the comma that was already there for me. And I want to get rid of this other question mark, so I have to highlight it and put in question 2. So oops, highlight question 2 and then click on the arrow to put that one in. Now I have to put in my own commas and everything, depending on however many you want to calculate together. The rest you do on your own. So put in the comma for the third one, highlight the third one, move it over, put in another comma, highlight the fourth one, move it over. So there was just 4 questions about shyness, and we stopped there. Hopefully you all are caught up. Should I stop and wait? Okay, I'm going to keep going. And then click OK. All right, now it's telling me what it did. It executed the compute variable, and it gave, this is the label I gave it, equals the mean of these 4 variables. You can kind of read it, right? And let's go see. Here it is, total shyness score. And it, this time it labeled it correctly. It told me it's a scale variable, and oops, and it is a numeric. Yay, jackpot. Okay. I believe that should do it for everything we wanted to. Let's see. Yeah, that's all I wanted to do with this data set. As far as that is what we call cleaning and coding data in SPSS. So for us, what we need to do, or what you will be ending up doing in what, okay, let me get that. What we need to do here is, these are the calculations that you would do for your homework, which we're doing now together, don't panic. And once we finish them, you're gonna save the output file from SPSS, and that's what you're gonna upload to Canvas. The output file from SPSS, just upload that to Canvas for this exercise. So we're going to do frequencies, descriptives, correlations, chi-square. That is not chi-square, it's chi-square. It's not T. Then independent samples t-test, and one-way between subjects ANOVA. So let's get started. For frequencies, let's see, do I have it here? I do. So to do frequencies, your data should be categorical. And as you can see, frequencies are univariate analysis, meaning you're just doing analysis for one variable. And it should be categorical for frequencies. So let's go to the data and find out what variable can we evaluate with frequencies. And you can see here, based on this, you can see that the class is a categorical variable, so is gender, and so are the rest. Oh, and by the way, I forgot to recode gender. Let's do that real quick, because I think it's a string right now. Yes. SPSS doesn't like words. So we're going to transform this into numbers. We're going to recode it into numbers. So go to transform, recode into different variables again, and hit reset. So it clears it all out for us. Put gender in there, and we're going to put gender recode. Change. So when you are redoing a something that is written out, it has to be spelled exactly the same way it is in SPSS. So if I had some people just filled out an application and they didn't just click in something that was already spelled correctly or whatever, however many variations of the way people entered it in, it's going to count it as an individual data point. So if they misspelled it and misspelled male, for example, and spelled it M-A-L and forgot to put in the E, they're going to count that as a totally separate variable. So sometimes it's good to automatically, create a variable on your own, like we have here, instead of saying what's your gender and then give them a space to enter it in, because you're going to end up with a lot of messy data for every time you do that. So let's go back. And also it's important to realize that it does distinguish the difference between capital and lowercase letters. So it does know the difference between uppercase and lowercase. So our data is spelled with an uppercase letter for both of them. So for male, we're going to tell it, treat males as ones, and treat females, which is also capitalized, as twos. Continue, and then OK. Now, so I don't forget which ones are males and females, here's my gender recode. I'm going to slip that up here. Whoops. I'm going to slip gender up here next to this one. I'm going to tell it what those values were. The ones were males, and the twos were females. Hit OK. And I really don't want decimal spaces, so let's not put them in there. Okay, there we go. So now it should show these as ones and twos there. Okay, so let's get back to our analysis. So to do, I believe the first one was frequencies. You go to Descriptive Statistics, and if you recall, we have to use categorical variables and only one variable. It will only calculate results for one variable at a time, but you can, in SPSS, do a calculation for several at a time. It will still only look at each individual variable and give you an outcome. It won't put them all together, in other words. It's still doing singular tests for them. And you can see by these little pictures, I guess is the word, the bubbles represent nominal data, and these little bars represent ordinal data. You can tell the continuous data by the rulers. So if I go find all the variables that have the bubbles and the bars and highlight them, I can move them over here, and it'll calculate a frequency for each and every one of them. And then if I hit statistics, I want to get a mean, median, and mode. And let's do a standard deviation, maybe a minimum and a maximum, and it will calculate all of that for me for each variable. So hit continue. If you want, you can get charts. This is no charts, but you could. You can use pie charts, bar charts. This comes in real handy if you do these calculations for your research project data. You can copy the charts and put them into your reports. So hit continue. And the rest is basically just telling how do you want it to come out. It's all automatically set to how we generally like to look at it. So we leave those alone. Here, you can choose to have frequency tables or not. So we'll keep them and click OK. Here we go. And you can see for gender, there are 138 cases number. See the N? And it gives me the mean. So if we know that men are 1s and girls are 2s, since it's above 1, that means that there are typically more girls in my psychology classes than there are men, by quite a lot, in fact. If this was below 1, that would mean there was more men. If it was closer to 1, I should say. It's closer to 2. That's how you read that. The median is the middle score. So if you laid them out all on a continuum from 1s to 2s, the middle score is a 2. That's probably because there are more girls usually than men in my class. And mode is a score that is occurring the most often. Here's the standard deviation. And it's telling me the max score is a 2 and the minimum score is the 1. And we know there's only 1s and 2s. And that same thing goes for the rest of them. Okay, so that's the first test, frequencies. It wants you to do descriptives. Now, if we look here for descriptives, you can see that to do descriptives, you need to have continuous data. So the reason for that is in frequencies, if you have, let's say you have 500 people who gave you their income, yearly income. So 500 different people will usually come out with probably 500 different answers, right? Well, you don't want a frequency for how often each of those answers came out. You'll just get a bunch of 1s. Like I made 539 or 53,672 last year, right? One person might answer. Another person might answer another one. And if you have 500 people, you're going to only have a frequency of 1 for each of those answers. So that's why you wouldn't use it on continuous data. You would only use it on categorical data. For descriptives, this is where you use continuous data because it gives you just, the means and standard deviations. It's really a very basic function. It doesn't give you a whole lot. In fact, although I'm going to show you how to use it, you can get the same information from frequencies as you do descriptives. And I'll show you what I mean in a moment. But first, let's show you how to do the descriptives. And you just put in your continuous data. And the same thing for the other one, although it is univariate, meaning one variable it only calculates for one variable at a time. You would put the continuous variables, all of them in there. Not this one, it's backwards. Total shyness score. It gives you the mean, standard deviation, and variance, and so on, the minimum, maximum. It can even show you, if you remember in our lecture, we were talking about skewness and kurtosis, where the bell curve leans, if you want it in these calculations. So click OK. and then click OK. Oh, I still have it to show bar charts, but that's okay. Let's look at the descriptives. So here, you can see it gives, now the variables are on this side and it's running across. So for age, the number of people is 138. The minimum value is, the lowest age is 18 in my class. The maximum has been 52. And on average, people are around 23 years of age. Okay, so I can get these same answers from frequencies, as you can see up here. You know, you get the mean, median, standard deviation, and all that. The only thing is, for every, you know, person's age, it'll give me how many times each one has that age. You'll have a whole long list, right? Well, you can stop it from doing that in SPSS by going to the frequencies and say I want to do the frequencies for all this, but I don't want the long list of values. You click this off. It'll take those off and just give you the means, median, and mode and all that for you. So you'll get that. And it here also gives you skewness and kurtosis. In fact, I'm not even sure why SPSS differentiates with the descriptives and frequencies. So
Professor, I have a question.
sure.
So when we're done running all the individual tests, like the frequencies and descriptives and then like so on, the page you're on right now, so do we just go to the top and then click save, and that's like what saves as the SPV file?
Well, you want to tell it, yeah, you can hit save. Make sure you save it in a place you can find it, and then just upload that to Canvas. Yeah.
Okay.
And this is the page, exactly. This
yeah, I just wanted to double check because I know that the like page that opens first behind that, like that's still up, and like anyway, yeah. Okay.
We call this the output, and we call this the data sheet. Yeah.
So are we turning in the data sheet?
No, you don't need to turn that in.
Okay, just the output sheet, and it'll have like everything on there, like frequencies, descriptives, like everything will just be on one document that we can turn into you. Okay, cool.
Yeah. Okay. All right, let's try correlations. Now I'm showing you how to sort of, once you've developed your own survey, you should be able to look at the questions now and know, did I just ask a categorical question or did I ask a continuous type of question, right? And based on that, you should be able to know and look back, well, what kind of test can I do? So here we're kind of going back. So if I want to do a correlation test, which is the next one, what do I need? Now we're going into bivariate analysis with two variables. To have a correlation, your independent variable and your dependent variable both have to be continuous. So now we're comparing variables. So this is comparing two questions on that survey, right? So I'm looking here. I can kind of tell here, I would have to compare two variables that have a ruler, right? Those are continuous variables. I'm going to switch over here to look at them easier. So here's a measure. Here's one, there's age. And all of these are also continuous. But we used all these questions, shyness questions, to come out with one total score, right? So maybe we'll compare age with shyness score. So let's try it. Analyze, correlate, bivariate. Analyze, correlate, bivariate. Oops, I missed. Okay. So let's say I want to check age and compare it to shyness. The good thing about SPSS, it lets you run a whole bunch of correlation tests all at once if you want to, and it'll compare 2 by 2 all the variables that you list in this box. So maybe I want to ask put in also the divorce questions, right? Self-divorce and others divorce. Now click on options, and it's usually good practice to go ahead and include the means and standard deviations when you run these kinds of analysis. So click in that and click continue. And the rest is here. We can see these correlations are going to be Pearson product correlations, and they're two-tailed tests. And a lot of what we can do is have SPSS flag the correlations that are significant for us, which is always nice. So then just click OK. All these are already set to what we typically like them to be set to be, so you don't need to touch them. All right, here's our correlations. To read this, you can see all the variables we stuck in there, and it gives us the descriptive statistics like we asked it for, the average age, which should be the same as the one we saw before with the standard deviation. The mean for our shyness score, remember we had 1 through 5, and 5 meant a lot of shyness or high shyness. And this actually goes a little bit past the midway point. So people tend to be a little more shy in my class for some reason. I don't know why. It's kind of a drag, you guys. And then for the self-divorce question, remember you asked 1 through 100, what's the chances you think of yourself getting a divorce in the future? And typically people kind of have a good outlook on their own possibilities of getting divorced. Around 26%, they think it's possible. But for others, they think others are maybe not as lucky as they are. They have not such a good outlook for others, unfortunately. I wonder what you can ascertain from that. I'm not going to go there. And so here are the correlation table. And the way we read this is, remember we were talking about the Pearson correlation. A perfect correlation is a 1, remember. A 1 or a -1, right? And a 0 is no correlation at all. And you can see going down, we have all the variables, and going across, we have all 4 of the variables we stuck in there. And it's comparing age to age, age to total shyness, age to self-divorce, and others divorce. And to be able to tell whether or not they're significant, you look at this sig. And for it to be significant, it must be 0.05 or less. So we can see here that when we compare age to total shyness score, there is no significance here. It's not 0.05 or less. So there's no difference, or there's no correlation, nothing that's connected with age and shyness. And same thing with self-divorce and others. And if you want to look quickly, it shows you here that these asterisks, this is what it means that it will flag significant results if it has an asterisk next to it. And we can kind of see real quickly, there is one. There is an asterisk next to self-divorce and others divorce. So what this is probably telling us is what we noticed here is for self-divorce, people tend to rate themselves quite a bit lower than others, and that's probably what it's picking up. And as you can see, there are 1s running diagonally, and that's because it's telling you these are perfect matches. Why would we have that? Well, it's because it's comparing a variable to itself. So of course it's going to be a perfect match. So that's why it's a 1. Okay. And that's how you read a correlation table. So if you have correlations, which you probably won't because we have experimental data or experimental research, not correlational research for this class. Okay, which means you're going to be comparing groups of people, like an experimental group to a control group, for example, or one group that's different from another group in some way. Okay, so what's the next one? chi-square. We can also in SPSS, it thinks of those as, it calls them crosstabs. Chi-square. So if you go to Analyze and then Descriptive Statistics, you go to crosstabs, and we forgot to look. What does it take to have a chi-square? To have a chi-square, you're comparing an independent and dependent variable that are both categorical, that have two or more groups, right? Okay. So in our data, we do have quite a few categorical variables. So let's just choose maybe a few of them. Whatever we put in here will be in the rows. You'll see them in the rows. And whatever we put in here will be compared in the columns. So let's look at maybe gender, right? And let's see. We can compare it to, well, really all of them, but let's just pick a few so it's not too confusing. Maybe sports, cooking, and travel. How about that? We'll put 3 of them in the columns to see the difference between genders and their liking for these different variables. And then you will click on statistics. You want the chi-square so you can tell if it's significant. And that's it. Then click continue. For cells, we want to have expected counts, and we want to see the percentages for the rows, columns, and totals. And that's it for that. Click continue. And let's see, clustered bar charts. Well, let's see what these look like. Let's see what they look like. All right, you can display some charts and then click OK. Okay. So here you can see it's telling us we're looking at these 3 variables compared to gender. And you can see here's the males, here's the females. And this is the first chart. They're looking at sports, gender compared to sports here. And if you go down here where it's the tests for it are, you look at these to see if there's a significant difference here. And you can see that they are 0.05 or less for their chi-square. So there is a difference between males and females and how much they like sports. And you can kind of see that for males, only one, I wonder who that was, didn't like sports. But on the contrast, I'd say the majority chose that they liked sports. For females, it's a little more spread out. They had a lot more that were willing to admit that they disliked sports. Okay, and here you can see they actually calculate totals and whatnot. For here, this is what we wanted to look at. We wanted to see the expected count to see if there's a big difference between what we actually had compared to what we expected to see if it was just, you know, normal, if there's no anomalies in the data or differences. And so they were kind of expecting to see a higher number for dislike in this area. And this could be why we're seeing a significance here. Yeah, it was expecting to see a little more spread out for the males, especially. Okay, that's how you read chi-square, and it put out some nice charts for us. You can see there's more women than men. Again. And here it did the comparisons for travel. There's no significant difference here because it's not 0.05 or less. And here's the cooking. And there's no significant difference here for cooking either. Okay. Let's do the next test. Where are we here? Oh, a t-test. For most of you, this is probably the test you're going to be doing for your own individual projects. What's required for a t-test? Independent samples t-test. For that, your independent variable should have two groups, and that should ring a bell for you. Most of you have an experimental group and a control group, right? Or maybe you're testing different color paper for tests or something like that, and you have two groups. And then the dependent variable is maybe like memory or reaction time. It's going to end up being a continuous variable. So let's do our analysis for that. So we know that we have to have a variable with only two groups for the independent variable. And in our data set, we know we only have one variable that matches that specification, and that's this gender, which only has males and females for it, right? And we can use that to maybe do a t-test to see if, let's look at if there's a difference in males and females and their expectation of maybe getting divorced in the future. This ought to be interesting. So let's do compare means, analyze, compare means, independent samples t-test. We're going to put the test variable, this is sort of backwards, self-divorce in here. And hey, it lets you put more in there. It'll run several t-tests for you if you want. So let's put the other divorce question in there. And now down here, this is where we put the grouping variable, the one with the two groups. Gender recode goes in there. And we have to tell it what its two groups numbers are. So you define groups. And remember, we said males are ones and females are twos when we recoded. So hit continue. Options is already set. It wants to have a confidence interval of 95%. That's typical. If you want more stringent parameters, you might put 99% or something like that. But we'll keep it there. And now we'll just hit OK. Okay, t-test. So pay close attention on how to read this when your research comes around. So we can see here, it tells you how many males answered this self-divorce question. 49 of them did, and 88 women answered this one. And it shows the means for males. On average, they said on about 26%, it's almost the same, in fact, 26% versus 25%. Others divorce, men had a lower rate mean for others divorce, so they have more of an optimistic outlook for others, I think, than females. Let's see maybe if there's a significance here. So let's look at the first t-test, which was males and females and their thoughts of self-divorce. The first thing, if you notice, there's something called Levine's test for equality, and that's just testing to see if your data is normal. It's a little more advanced, but if this was significant, then I would have to drop down to this second row here and look at this sig. Okay, but it is not significant. It is not 0.05 or less. So I travel along and I look at the second sig here. This is the significance test for the t-test. This is the significant test for the Levine's test. If Levine's test is significant, you look at this significant t-test. If it is not significant, you look at the top one. In this case, neither one of them are significant because neither one of them are 0.05 or less. And that does show with our means that they are nearly the same, right? They are nearly the same. So let's look at the other one, others divorce. First, we look at the Levine significance test, and you can see that it's not significant. It's not 0.05 or less. So I keep on that same line and move across. And this significance test, t-test, for this significance test for the t-test is 0.05 or less. So yes, there's a difference between males and females, a guess for how likely it is others will get divorced. There's a difference between how they feel. So I guess men, if we're going on these means, tend to have a more positive outlook for marriage for others for some reason. That's a research project right there. Find out why that is. That's an interesting question, right? See how research questions can just sort of pop up? It's interesting. Okay.
I keep looking at the standard deviations for.
Oh, yeah.
It's like 30% for men
That's-
for their self-reporting.
Oh, wow. That's
yeah,
big.
it's an insane standard deviation.
We may have some outliers there, so maybe. But that just means there's a large variance between scores. It's a little more flattened out right here for the second question. So anyway, let's move along. We'll keep it simple, you guys. So I just want to tell you also, so knowing all this and how to do SPSS and all this terminology I'm using as far as, t-tests and ANOVA and all that, knowing how to operate SPSS is only indirectly part of your grade. In other words, I'm not going to ask you, how do you do a t-test in SPSS on the exam? But you're probably going to need to know how to do it when you do, you collect the data for your research projects, right? So I just wanted to make sure that's clear, like you're not panicking, like, oh, how am I going to remember how to recode when the exam comes? No, I'm not going to ask those kinds of questions. But you will need to know how to do this when you're dealing with your own data for your research projects. Hopefully that gave some of you a little bit of relief. I've had people panic on me before, and I usually remember to tell you that way sooner. So I spent the last 40 minutes making people panic, maybe. All right, last test, one way between Subjects Anova. Okay. So to do that, let's look. One way between Subjects Anova. Here is independent variable is also categorical like the t-test, but you need to have at least three groups, 3 or more groups in this case. And it also requires a continuous variable for the dependent variable. And in our data, you can see, if you go to analyze, compare means, one way ANOVA. So the dependent variable's on top again. And so that means we need a continuous variable. So let's put in maybe a total shyness score. And let's go ahead, since it lets you do more than one test at one time, put in the divorce questions. And let's see. Now we need a categorical variable with at least 3 groups. And the only ones we have of that are these questions that how much people like sports and reading and so on. And we can only choose one. And that will go down here in this factor. So let's see, reading. Let's try the sports one again. That one seemed to pop out something interesting before. So for contrasts, we don't do anything to this. We're just going to leave it alone. But for post hoc, it's important that you click on Tukey for this. What this is, so an ANOVA gives me a score to see if there's a difference between all 3 of my groups in the sports in this case. But for a post hoc, it will compare 2 by 2. It will compare, number 1s to number 2s and number 2s to number 3s and 1s to 3s. These are like little t-tests after it's determined whether or not the ANOVA was significant. So click on Tukey and then click continue. And let's see, what was options? Oh, yes. You want descriptives and homogeneity of variance for the options. And then click, let's do a means plot. Why not? So we can visualize it. Continue, and then click OK. Okay. And here's the descriptives that we asked it to do. It's the means and standard deviations and so on. And as you can see, that these are all the continuous data that it's doing it for. Okay. Let's see. So for the descriptives, I also should point out. So for example, if you're looking at it here, this is the total shyness score and the people who said dislike on the sports question and what that mean was. So it's comparing the two, and the one that said don't care and the one that said like, and the total. All right, that's how you read that. Homogeneity variance, you do not want this significance score to be significant, because then it's telling you your data is not normal, but you want it to be normal, and none of these are significant, so yay. Here is the main test, the ANOVA test. Here you're looking to see if there's significance between the groups, between the likes, don't cares, and dislikes for each of these scores, right? And you look at the significance score. Is it 0.05 or less? And going down the board here, you can see two of them are significant. The one for the shyness and the self-divorce. There is a significance. So, well, which ones are significant between those three groups for shyness and self-divorce? And where you get that question answered is in the post hoc tests, which are little t-tests, right? And this also flags significance comparisons, okay? So here you can see an asterisk. It's saying, hey, this comparison is significant. And if you look here under the SIG test, that is 0.05 or less. Yeah. And what this is looking at is it's comparing the shyness scores between those who dislike sports and those who like sports. And there's a significant difference between shyness scores and those who like and dislike sports, interestingly enough. And to find out what it is, you go back up to the dislike and like for shyness, and let's look at their means. So dislike, their mean is 3.72, right, for dislike. And the mean for like is 2.5. So those who like sports are less shy, because remember, 5 means more shy. So they had a lower shyness score than those who dislike sports. Wow, that's interesting. Okay, so self-divorce. Let's see if there's, we can go back to the post hocs. Here, let's see, don't care and like is also different for shyness score. So let's see. Don't care and like, yeah. So overall, people who like sports have lower shyness scores. Okay, so self-divorce, get that off. It's flagging this one here. It's 0.05 or less. So people who don't care about sports and those who like sports, there's a significant difference between their thoughts of self-divorce. So like and don't care. Like and don't care. So people who like sports have much less idea or much less prediction of getting divorced than people who don't care about sports. Interesting. That is so interesting. And so that would end the analysis of this, because when we looked here at the ANOVA, we saw that this test for others' divorce isn't significant. So we don't need to bother looking at the post hoc test for that. And that's how you read it. Okay. And when you write out your, so for example, if I want to look at the t-test, or even the ANOVA for that matter, you can see it gives you all these like demographic questions, the number of people, the mean, standard deviation, and so on, the degrees of freedom and the significance and so on. When you are writing your outcomes on your research papers, you can go to the toolbox, find, let's see, statistics and results. And if you look here at the reporting statistics in APA format, click on one of these articles. Pretty much all of them give you similar information. And so say I had to do an ANOVA for my paper, and now I need to report it. And I just ran the analysis doing what I did. There are specific ways to sort of phrase your results or how you put it in writing. And this gives you example sentences for that. So if you scroll down here, it tells you how to report descriptive statistics, for example. You would write it exactly like this in your paper. Pop in your variable names and then fill in your numbers for, standard deviation, for the means, and so on. But for ANOVA, let's see, well, here's the t-test. So if you had a t-test, you would put in exactly this sentence, but then fill in the two groups that you had along with the dependent variable, and fill in where the means and standard deviations, the degree of freedom, which is right there, the p-value, and so on. And I showed you how to calculate Cohen's d for our Stroop paper. You might go back and look at that. Here's the paired samples. That's probably the one you're going to be doing, or independent samples, I should say. We did a paired samples. Here's the independent sample sentence. I think most of you will have that. There might be one person or one group that has the paired samples. And here's the ANOVA sentence right here. Copy and paste that, plug in your own information, and that's how you would write it in your paper in the results section after you've done your research and collected the data. Okay, so all you have to do now for this assignment is save and upload to Canvas, and you're done. Whew. I have 5 people who stuck with me. I can't believe that was a doozy, huh? Okay.
I mean, I'd rather have all the information now than have to email you and attempt to explain what the heck I'm doing in SPSS in an email. So
that will be hard on some people.
Yeah.
Yeah. Hopefully you guys get it. We're going to be doing more on Wednesday. That'll be more advanced statistics with more complicated data, I should say. But we won't have to code the data that time. Okay.
Well, thank you. Bye.
You're welcome. Thanks, guys. Bye, Sabrina and Carlos.
I had a quick question.
Okay.
It's not about like the SPSS or anything.
Oh.
So I was like, I just like being proactive. So I was trying to find like for my intro section of the research paper, I was just looking for references.
Mm-hmm.
And I just wanted to make sure, because I've looked like everywhere. I've looked at the OCC library. I've looked at like APA PsycNet. I've looked everywhere, and there's not any like exact matches to the experiment that my group is doing. They don't have to be exact, right?
Right.
Okay, because there's a lot, because my group is doing the one where we're having some people eat breakfast and the others are not, and then they're doing the reaction time test. And there's a lot of them that have like, oh, these people didn't eat breakfast, and we gave them like focus and attention tests or like cognitive functioning tests.
Oh, okay.
And they've done like, there's tons of them where they do it with like school children. Like, can I use those?
Yes, absolutely.
Okay, perfect. So
Yeah.
they just have to be
Perfect.
like within the general topic, because I found like 6 that like might work so
That's
far.
perfect.
And
Yeah,
then I'm
you're
just
not
gonna
gonna-
like read through them really carefully and like find out like if they're like close enough or if they're like valid sources. Obviously, I've just been trying to find some like now.
Yeah. If you find something that's similar to what you're doing, I mean, it's still looking at, you know, the effects of whether a person ate or not and their abilities. You can use that. You can say, well, in this study, they found this and this and this. So we think for our study, this will happen.
Okay, cool. So it just has to be same general topic, and it doesn't have to be adults. Like, it can be like a test on children that they did at some point.
Absolutely.
Because there are tons of those where they're like, oh, these kids didn't eat breakfast and they did like bad on a test or something.
Interesting.
Yeah.
Oh, that's good. Well, you know, it's a sign that maybe your research is more unique, you know, that others haven't studied it.
Yeah, I found like a few on the OCC library. I've tried so many different like terms. I've tried like fasting, I've tried reaction times, cognitive functioning, and there's just like not very many.
Oh,
but there's a lot for like the younger like kids, like 13 to 18 or something, that are like in school. So like I'll just use the best ones I can find, just the most valid ones I can find.
Yeah, exactly.
Okay, perfect. Thank you so much.
All right, thanks, Amanda.